This video is about switches, which is a name for a bridge with several ports. As you can see from the pictures, switches can have relatively few ports or many ports. In addition, their capabilities can be quite different, so that you have also significant price ranges between 20 euros and several thousand euros. The price differences are related to bit rates, management functionality and backplane capabilities. Bigger switches use line cards with a set of ports. The line cards are interconnected via the backplane. The use of switches implies that a star topology is used. Except of the use of fiber for longer distances or higher bit rates, twisted pair cables are used to connect to the ports. The plug for that is called RJ45. Now we start to take a look to which extent a switch prevents that collisions happen. On the bottom of the slide you see icons for frames which are considered. Each frame is received by the switch on one port and forwarded on another port. In this first scenario we have frames which are forwarded inside of different line cards. This can happen independently from each other so that we have no collisions. On the next slide we have a situation where two frames are received on one line card and need to be forwarded to another line card via the backplane. Backplanes have capabilities to allow for such parallel communication, so that this should not pose a problem. On the next slide we see a parallel communication on one line card. In the past, a whole line card was a single collision domain, so that problems occurred in such a case. However, line cards nowadays are ready for such a parallel communication, so that there is also no collision in this situation. Here is again a new situation where two frames are sent to the same destination, or at least to the same destination port. In this scenario, the switch can buffer frames. Certainly, buffer sizes are limited, so that frames are lost if there are large streams of frames of this kind. However, this kind of conflict is then still no collision on the medium, but a buffer overload on the switch. In this situation, a system that is connected to a switch port, for example an end system or another switch, wants to send a frame to a switch port, but in parallel a frame is sent by the switch on the same port. If we have a half-duplex configuration on the link, then there is a collision on the medium. Ethernet has been designed for half-duplex, which is unavoidable in a bus topology. So therefore it is not possible to send and receive at the same time. However, on such a switch port where we have a one-to-one relation to the connected system, the use of the twisted pair cable, which comprises 4 pairs of copper strands, can be changed so that parallel communication in both directions becomes possible. In this way, we eliminated the last possibility for collisions on the medium. As a conclusion, the CSMA-CD method is then not needed anymore. However, if it is still implemented, this does not have an important impact. Then always a free medium is observed, the transmission starts immediately, and then the collision detection always indicates that there is no collision.